One of the world's most advanced research facilities, the European Spalation Source, ESS, will be built near Lund in southern Sweden. The facility will be used to conduct research in materials, research that could lead to new, intelligent materials such as superconductors, new medicines, more effective windmills and the such like. Danish researchers are centrally located in the new research, and the head of the Niels Bohr Institute in Copenhagen, John Renner Hansen, is excited.
Oh, it was fantastic. I mean, we've been working on this project for quite some time now. I mean, many years. It's a fantastic opportunity for Denmark at various levels. It's a very, very good opportunity for our researchers that they have in their backyard the possibility to do research. They can bring their stuff over there, their experiments over there in a very few hours, and then go back home and sleep in their own beds instead of traveling to the US to do the same thing or traveling to Japan.
The research at ESS will be strengthened even further by the simultaneous construction of the world's most powerful synchrotron and X-ray radiation facility, MAX-4. Together, ESS and MAX-4 will create a world-leading centre for materials research. One of the Danish researchers who will be part of an international team designing and developing instruments to be used in ESS is Kim Lefman, and for him, ESS is like trading a Trabant for a Bugatti.
ESS is going to be a wonderful instrument, really marvelous. We can see things that we today can only dream of seeing, or can just see a faint shadow of. My own research is within superconductivity, so we study materials that lose all electrical resistivity below a certain temperature. And the question is why these materials become superconducting. And with neutron scattering, we can today see some part of the truth, but we believe that with ESS we can be able to see the whole truth and therefore get a solution to this problem.
Kim Lefman and the other researchers use neutrons in their research. The technique that's used to produce the beams of neutrons is called spallation. The facility consists of 4 important sections. In the ion source, the protons are generated and used to release the neutrons from the target. The protons are then accelerated through a linear accelerator before reaching the target station where the separation of neutrons, the so-called spallation process, takes place. In the linear accelerator, the protons are accelerated close to the speed of light. When the protons reach the target station, they impact the atoms in the target material, which emit the neutrons. The neutrons then travel through beam guides out to the experimental stations, the so-called instruments. Thanks to beams of neutrons, researchers can study sensitive samples like biological materials, which can be damaged if they're examined using X-rays.
If you compare to the Paul Institute, where I usually do my experiments, we will have the number of neutrons will be a lot greater. It will be like factor 100 or 1,000 more than we have today. If you compare to the American neutron source, SNS, which is just being built or just being completed as we speak, then we will be roughly a factor of 10 better, depending on the actual experiment. And these extra neutrons will enable us to see things that we cannot see today.
It's not only the researchers who'll benefit from ESS, other sections of Danish society will also benefit from the proton accelerator.
For industry, for education, for research, everything is just perfectly timed for the evolution of Danish research. And from my point of view, there is also the support from the university is there, the support from the government to evolve these things, I hope will be very strong, because this is a great opportunity.
The research can be applied within a number of important areas. ESS can be used to find new ways to create and store energy. Knowledge gained with the help of neutrons exists in materials and devices in our everyday life. Researchers can study proteins and other biological materials and thereby develop more efficient medicines with fewer side effects. With nanotechnology, we can create new materials with improved characteristics. The technique has been used for developing the properties of paint, which is both weather-resistant and environmentally friendly. The ESS can be used to develop new technology, which cleans polluted soil without losing its nutrition. With new materials, we can reduce the exhaust emission from engines and create more efficient combustion processes. ESS has already given Danes work. It's Denmark that has the responsibility for developing all of the software which needs to be ready when ESS is finished. The excavation work for the accelerator will begin in 2012. The researchers expect the facility to be ready for use in 2018 and to be completely finished in 2025.